In this example, we want to use synthetic division to determine whether 3i is a zero of the function h of x equals x cubed minus 2x squared plus 9x minus 18. Now, we've already worked an example similar to this, except in this case we have an imaginary number that we're checking to see if it's a zero of our function. So again, if 3i is a zero of the function, then h of 3i will equal 0. If h of 3i does not equal 0, then 3i is not a zero of the function. And so we're going to use the remainder theorem in order to evaluate h of 3i. So in other words, we're going to divide our polynomial by x minus 3i. So we're going to use synthetic division to do that. So I'm going to write down the 1, the minus 2, the 9, and the minus 18. And then since I'm dividing by x minus 3i, I'm going to write 3i out here. So going through the synthetic division process, we're going to drop down the 1, and then we're going to multiply 3i times 1. So we have 3i. 3i times 1 is 3i. Now notice we have negative 2 plus 3i here, which is going to be negative 2 plus 3i. Now I have to multiply 3i times negative 2 plus 3i. So I'm going to do that over here on the side. 3i times negative 2 plus 3i. We have to distribute. 3i times negative 2 is negative 6i. 3i times 3i is plus 9i squared. But remember, I squared is negative 1, so I really have 9 times negative 1 here, which is negative 9. So that is really negative 9. So I have negative 6i minus 9, or negative 9 minus 6i. So negative 9 minus 6i goes here. Again, that came from 3i times the negative 2 plus 3i. Now add 9 plus negative 9 minus 6i. 9 minus 9 is 0, and so we only have minus 6i. Multiply 3i times minus 6i. Well, we'll do that over here. 3i times negative 6i is going to be negative 18i squared. But again, I squared is really negative 1, so I have negative 18 times negative 1, which is going to be positive 18. So this is 18. Negative 18 plus 18 is 0, so my remainder is 0. The fact that we get a remainder of 0 means that h of 3i is in fact 0, which means 3i is a 0 of our function h of x.